Hi students, I'm Dr. Deepak. See, I'm going to handle Transceiver as a vertical subject for you. You know all what is RF? Last semester you have studied the basics of RF circuit design. We have some small recap in this RF. So RF stands for the radio frequency. It represents the oscillation rate of electromagnetic waves. The frequency is measured on X, which is equal to number of oscillation cycles per second. You can refer to frequencies as high 300 gigahertz to and as low as 30 kilohertz. So this RF applications are include radio broadcasting, wireless communication, for example, 5G, cell phones, Wi-Fi, Bluetooth, and RF remote control, RF remote sensing, and satellite navigation, and imaging also. So RF waves can have other names such as microwaves or millimeter waves. So microwave often referred to radio waves with wavelength ranging from 1 centimeter to 10 centimeter. Millimeter waves often refers to radio waves with a wavelength ranging from 1 mm to 10 mm. So these are the radio wave frequency ranges we are using in current technologies. So what are the types of circuits available in RF circuit design? So we are going to see those circuit parts in this subject. There will be low noise amplifier, power amplifier, local oscillator, mixer, filter, switch, and transceiver. So the transceiver is one of the main part in RF circuit design. This is our subject. So in RF circuits, they are analog in nature with continuous time and stimulus and response. So RF circuit design is involved with the top-down design and implementation process. So we will see one by one uh, in forthcoming chapters. So an RF circuit is a special type of analog circuit operating at very high frequencies suitable for wireless transmission. So one important feature of this RF circuit is the use of inductive elements to tune resonance circuit operation and around specific radio carrier frequency. The primary difference between RF design and low frequency analog design is the type of analysis performed on the circuit. In RF design, the steady-state operation of primary concern. The behavior of the circuit is often modeled in frequency domain with attention focused on signal fidelity, noise, distortion, and interference. When modeling a modulated signal on RF carrier, a hybrid time frequency domain analysis is more efficient, where time domain focus on the dynamic signal changes and frequency domain focus on the RF carrier and its harmonics. In analog design, circuit stimulus is treated as a continuously varying signal over time. In concept of wireless communications, analog design refers to low frequency or baseband circuit as opposed to the RF circuit. In this RF circuit, so we go for our syllabus. So this is our syllabus, RF transceivers. The code one is a 21EZA01T. So in this, the first unit is CMOS transceiver specifications and architecture. So in this, we will study about MOSFET basics and its noises, what are the noise types, and the parameters involved in transceiver design, and the architecture of the transceivers. That means the receiver architecture and transmitter architecture. In receiver architecture, we will see about heterodyne receiver, homodyne, and image rate and low IF architectures. In transmitter, we will see about direct up conversion and two-step conversion scheme. And second unit involved in impedance matching network and amplifiers. You already know about impedance matching networks. Here also we can go a small review about S parameters, Smith chart, and passive IC components, nothing but RLC. You already know resistor, capacitor, and inductors. These are the passive components. And what is impedance matching, and what are the impedance matching networks and amplifiers. You already know about amplifiers, that is common gate and common source, and it's a constant open time constants involved in the impedance matching networks, and high frequency amplifiers that involves uh, low noise amplifier and power match and noise match also. And the third unit will be the feedback system and power amplifiers. There are the four types of power amplifiers, that is class A, class C, B, class C, D, E, and F, and some linear things involved in the feedback systems. And the fourth unit consists of filters and mixers. We can see about the overview of resonators, filters configuration, and basic characteristics of mixers, passive down conversion and mixers, active down conversion mixers, and single and double balanced mixers. In fifth unit, we will see about frequency synthesis and oscillators. Frequency synthesis and its types. There are direct signal frequency synthesis and integer n frequencies, then basic oscillator model. These are compressed in the fifth unit. So this is your textbook. For author will be the Lee T, the design of CMOS RF integrated circuit, the second edition. This will be your textbook. And Razavi RF microelectronics, the second edition. This will be your another one textbook. Most of the 5 units will be covered in these two books. So you can also refer to these books also. So in first unit, the CMOS physics, transceiver specification and architecture. So here in this PPT, I separated the first unit will be in 2 sessions. So the first session is this one. So here we will see about introduction to MOSFET physics, noise and its types, and transceiver specifications and its parameters. So in second part, we will see about transceiver architecture. So in this session, we are going to see about MOSFET physics. We already know what is MOSFET. MOSFET nothing but metal oxide semiconductor field effect transistor. It is one of the field effect transistors. So there are two FET transistor available. That one is a JFET, another one is a metal oxide semiconductor field effect transistor. So this is the main application of this MOSFET is to use to amplify the signals. So also it can be used to switching the signals also. The ability to change conductivity with the amount of voltage can be used for amplifying or switching electronic signals. MOSFET are now even more common than the BJT in digital and analog circuits. So we will see about what is MOSFET. MOSFET nothing but metal oxide semiconductor field effect transistors. This is commonly known as MOSFET. These are the electronic devices used to switch or amplify the voltage in circuit. It is a voltage controlled device. We can say it can be constructed by 3 terminals, that is source, gate, drain and body. So these are the 3 terminals available in the MOSFET. When you construct a MOSFET, there is a p-type semiconductor that forms the base of the MOSFET, and there are 2 types of base are highly doped with an n-type impurity which is marked as n plus in the diagram. From the heavily doped regions of the base, the terminals, source and drains originate. The layer of the substrate is coated with a layer of silicon dioxide for insulation. A thin insulated metallic plate is kept on the top of the silicon dioxide and it acts as a capacitor. The curved terminal is brought out from the thin metallic plate. A DC circuit is then formed by connecting the voltage source between these two n types of regions. So how this will be work? The working principle of MOSFET will be when voltage is applied on the gate, an electrical field is generated that changes the width of the channel region where the electrons flow. The wider channel region will give the better conductivity of the device. There are 2 types of MOSFETs here, that is P channel and N channel. And also we can classify it based on the working mode of the MOSFET. By working mode, we can say there is an enhancement mode, another one is a depletion mode. So in enhancement, we have 2 types, P channel and N channel, and depletion mode also we can have P channel and N channel. So what is depletion mode? When there is no voltage across the gate terminal, the channel shows maximum conductance. When the voltage across the gate terminal is either positive or negative, the channel conductivity will be decreased. So what will be enhancing mode? When there is no voltage across the gate terminal, then the device does not conduct. When there is a maximum voltage across the gate terminal, the device shows the enhanced conductivity. So N-channel MOSFET are abbreviated as a NMOS, which is symbolically shown as a in this figure NMOS and PMOS. We can see these symbols of the N-channel MOSFET and P-channel MOSFET. So when you go for the MOSFET characteristics, there are two characteristics available in MOSFET. That first one is the drain characteristics, another one is the transfer characteristics. There are two types of characteristics available in MOSFET. First one is the drain characteristics. Second one is the transfer characteristics. The transfer characteristics shows the response between the output current and input voltage, and the drain characteristics shows the output current with output voltage. So in this we can see with increasing voltage, the current flowing through the terminals increases the with voltage. You can see this in graph. Which is more than the threshold voltage is the condition of flowing current. There are the three regions available in this characteristics. First one is the saturation region. In this, the drain current is very constant. Another one is the cutoff region. When it cannot achieve the threshold voltage, the MOSFET will be remain off. The important terms available with the characteristics is pinch off voltage or threshold voltage. Pinch off voltage is nothing but the voltage at which the channel of the MOSFET closes is called the pinch off voltage. And the threshold voltage is nothing but it defined as a gate voltage at which the significant current starts to flow from source to drain. So another one important parameter here, channel length modulation. This is referred to where the effective channel length of the MOSFET decreases as the drain source voltage increases beyond the saturation. This results in a slight increase in drain current even in the saturation region. So this is called as a channel length modulation. Another one important parameter is a body effect in MOSFET. This is refers to the phenomenon where the threshold voltage of the MOSFET changes due to the voltage difference between the body and the source terminal. So this effect occur in a MOSFET because the body is often connected to the different potential rather than the source. It leads to changes in the depletion region and other surface potential of the MOSFET. So another one is an important function of the MOSFET. It can be used as a switch. So this is a circuit for the uh, switch operation in MOSFET. Here the drain terminal of the MOSFET is connected to the supply voltage and the drain resistor RD is grounded. So further it has the input voltage Vi that is applied to the gate terminal while output V0 is drawn from the drain. So next one is the noise. So associated with the RF circuit design. So noises in RF systems, there are thermal noise, short noise, flicker noise and popcorn noise. Thermal noise nothing but it occurs due to temperature which leads to random movement of charges. Short noise nothing but it's time dependent fluctuations in the circuit. Flicker noise nothing but it almost occurred in the all electronic components and inversely proportional to the frequency. Popcorn noise nothing but a sudden impulse. So this is a circuit for the thermal noise.